Welcome to this explainer. Today, we're diving deep into the bleeding edge promises and, honestly, the pretty harsh realities of deploying the MiniMax H3 open weight model. Now, if you've been following the AI space even a little bit lately, you've absolutely seen the buzz around this one. But what actually happens when you try to bring this kind of tech home? We're going to cut through the marketing hype and look right at the hardware reality. All right, let's jump in. So here's the ultimate dream, right? Generating 15 full seconds of breathtaking 2K AI video, totally perfectly synced with native stereo audio, right on your own machine. No cloud subscriptions, no internet connection needed, just pure, unrestricted local generation. Sounds kind of like science fiction for consumer hardware, doesn't it? Well, today we are going to figure out if that dream is actually a reality with the MiniMax H3 model, or if there's just a massive catch hidden in the fine print. To get to the bottom of all this, here is our roadmap. First, we'll look at the MiniMax H3 promise. Then, the company behind the model. Third, we'll peek under the H3 hood. Fourth, we've got the open weight reality check. And finally, the software and hardware requirements. Let's get going. Let's kick things off with Section 1, the MiniMax H3 promise, redefining open weight AI. The capabilities we're talking about here literally represent a generational leap in what you can publicly download. The magic word here is unified. You see, older video models, like MiniMax's earlier Hey Ludo series, well, they really fragmented everything into these separate, clunky pipelines. You'd have one model for text to video, another one for images, a completely different one for editing. It was a lot. But MiniMax H3 collapses all of that into a single unified diffusion transformer, or DIT. It jointly understands text, images, video, and audio all at once. And the result? It can pump out 1440p video, that's 2K resolution by the way, alongside crisp 32 kHz stereo audio simultaneously for up to 15 seconds. Up until now, syncing high-fidelity stereo audio natively in a single pass, that has been a massive hurdle for open-weight models.
Moving on to Section 2, the company behind the model. Who is MiniMax? They are a Chinese AI company that has been moving at absolute breakneck speed since they were founded back in December 2021.
Just take a look at this rapid product evolution. They started out in October 2022 with the Glow app, where users could basically just chat with virtual characters. But that exploded. They hit 5 million users in just 4 months. Then, by the summer and fall of 2023, they launched Talkie for international markets and Xingye in China. And now, hitting August 2026, they are totally commanding the industry's attention with their Halo AI platform and this MiniMax H3 release. They've essentially gone from simple text chatbots to state-of-the-art multimodal video generators in less than 4 years. Crazy, right? But that kind of speed? It comes at a staggering cost. Look at this number. Negative $1.87 billion. That was their net loss just for the year 2025. Now, they did bring in around $79 million in revenue, sure, but that is just completely swallowed up by that massive $1.87 billion loss. So why does this even matter to us? Well, it highlights the sheer astronomical cost of the computing power it takes to train a foundational model like H3. They are literally burning billions to push this tech forward. With that context in mind, let's see what all that money actually bought in Section 3, under the H3 hood technical architecture. We're going to break down the actual mechanics of this massive model. All right, let's get into the core specs of this diffusion transformer. It's got a hidden size of 5376, operates across 50 layers, and boasts a whopping 33 billion parameters. And crucially, its native precision is BF16. That's brain floating point 16-bit. The big takeaway here is that this is absolutely not some lightweight, mobile-friendly model. At 33 billion parameters in BF16, this thing is a heavyweight beast. I mean, it requires serious memory just to load it into a graphics card, let alone actually run inference on it. So how does this translate into usable software? Well, MiniMax H3 isn't just one giant file you download. It's actually shipped as 2 separate task partitions that share the same runtime. First up, we've got the FL2VA partition. This one handles your pure text to video and audio, as well as frame condition generation, where you give it a starting or ending image. Then, on the other side, is the Ref2VA partition. Think of this as your reference-driven workhorse. If you provide a picture of a person and an audio track, this partition is what animates them and lip-syncs them to the audio. They're each self-contained pipelines, and you just swap between them depending on whatever you're trying to create. And now we reach Section 4, the big wait what moment of our explainer, the open weight reality check, missing pieces and legalities. Because as you're about to see, what you can actually download to your computer isn't quite the whole story.
All right, here is that reality check. The official MiniMax H3 system, it actually has 4 main parts, but only 2 of them are open weight. The stuff you can run locally, the H3 base FL2VA and the H3 base Ref2VA models, well, those max out at 768p resolution. The missing pieces are completely locked behind MiniMax's closed cloud API. You've got Context IR, which does all the heavy lifting for interpreting complex prompts and planning instructions, and even more importantly, H3 Regenerate 2K, the module that actually takes the base video and upscales it to that highly advertised 2K resolution. Yeah, that's closed too. So a fully local run, it only gets you the 768p base result. True 2K generation is still firmly stuck in the cloud. And there's another hurdle. You have to read the MiniMax H3 community license very carefully. It explicitly excludes users in the United States, the European Union, the United Kingdom, and South Korea from its applicable territory. If you or your organization are based in these major global markets, you literally require separate, specific authorization from MiniMax to use these weights legally. Just because it's in an open repository on Hugging Face doesn't override those terms. MiniMax is pretty clear that their hosted API is globally available for anyone who can't use the open weights, though. So, let's say you have the legal right to use it, and you're totally fine with 768p base resolution. What does it actually take to run this massive 500 gigabyte repository? Let's get into Section 5, Software and Hardware Requirements. Deploying the beast. Deploying a 33 billion parameter model is, well, it's a pretty harsh hardware reality check. If you're sitting there with an 8 gigabyte consumer VRAM card, the community has figured out ways to squeeze it in using heavy quantization, basically compressing the model so it fits. But you are looking at an agonizing 20-minute wait just for a tiny little video clip. Once you step up to the 12 to 32 gigabyte consumer tier, using ComfyUI becomes pretty practical. But be warned, it requires massive offloading to your system's CPU and standard RAM. Honestly, it isn't until you hit that 48 to 80 gigabyte multi-GPU tier that you actually get enterprise-grade performance, using server runtimes like SGLang or vLLM. To break down your software choices simply, if you're a creator running a single consumer NVIDIA GPU, ComfyUI version 0.30.up is definitely your easiest, most visual route. It even features official pruned files that drastically cut down that initial 500 gigabyte footprint. But if you're an inference engineer running, say, 2 or 4 massive server GPUs, you absolutely want to look at SGLang or vLLM-Omni for proper distributed execution and API handling. Now, for the enterprise users on AMD architecture, the deployment pipeline is definitely highly technical, but it is super streamlined. You basically pull the specific ROCm Docker image, install the runtime using AMD's custom AI kernels for maximum speed, and then just launch your service. But hey, even if you are at the absolute top end of the consumer spectrum, there is a severe hardware warning we have to talk about. If you're trying to run the official server profile for, say, 2 top-tier 5090 GPUs, the layer-wise offloading strategies demand an astronomical 384 gigabytes of standard host system RAM. So it really isn't just about having the best graphics cards. Your entire computer's architecture has to be massive just to feed this beast effectively. Which leaves us with one final, pretty provocative thought to wrap up this explainer. Think about it. With open weight models demanding hundreds of gigabytes of system RAM, those agonizing wait times on consumer cards, key upscaling components locked behind APIs, and strict community licenses straight up walling off entire continents, is the era of true decentralized local AI generation slipping right back into the hosted cloud? It's a huge question that every creator and developer really needs to grapple with as we move into this next generation of AI. Thank you so much for joining me for this explainer, and remember, always keep questioning the hype.